Okay, let's try this again. So we did the do now in class, and I introduced you to the concept of E based on $1 that is compounded at 100% interest for a year. And you look that as you compound more times within the year, the amount that you have gets closer and closer to this value of E. So anytime the problem says that it's going to compound continuously, we use the PERT formula. The final amount is equal to the principal times E to the RT, interest rate time. We did this example. If you weren't in class, please take a screenshot and get this in your flip book. Okay. An example here, a population of 950 bacteria grows continuously. That tells you were using the PERT formula at a rate of 4.75% per day. Okay, so our principal or initial amount is that. Our rate is going to equal, moving the decimal 2 places to the left, 0.0475. So I'm going to use, instead of A equals, I'm going to use N of T equals 950 for the initial amount, E to the R T. Okay, I use N of T for the output, so I have to use T as the input. And explain my reason for the choice of base. I used a base of E because the growth was continuous. Now determine the bacteria population after 36 hours to the nearest bacterium. Now it says 36 hours, however, this was a rate per day. So in 36 hours, how many days is that? I'll divide it by the 24 hours in a day and find that the time is 1.5 days. So I'm going to plug in 1.5 for T. Sorry for the background noise. I hope it's not too bad. I'm doing this in the cafeteria now. To the 0.0475 times 1.5, and then we're going to have to round. So in the calculator, I'm going to put 950 E to the 0.0475 times 1.5. Okay, and to round to the nearest bacterium, it's 1020. Okay, next problem. They give us a function P of T that models the population of a city in millions T years after 2010. As of today, consider the following two statements. The first statement is that the current population is 110 million. Now, this coefficient that's 110 million, that means the initial population. And when is the initial population going to happen? In the year 2010. So that is not the current population. That's the population when this function started in 2010. Then the population increases continuously. Well, that looks possible because it's a base E, so continuously, by approximately 3.9% per year. That would be 0.039, and that is very close to the exponent coefficient right there for time. For rates. So it looks like 2 is true, but 1 is not. Okay. Next one, a savings account has an initial value of $50. The account grows 2% interest rate compounded n times a year according to the function below. So this one, instead of being compounded continuously, is being compounded n times a year. So read the 4 choices to see which statement about this account is true. As n increases, that means the number of times it's compounded annually increases, the amount of interest per year decreases. That's not true. Okay, the amount of interest is going to keep increasing. I'm going to go across. As the value of n decreases, so it compounds less in a year, the amount of interest per year increases. No, the increase or decrease in interest is based on the rate, which is constant. So no. As the value of n increases, the value of the account approaches the function, and this is yes, this is the answer, because as the number of times compounded annually increases, you get closer and closer to this base of E, which is your continuous growth. Okay, as in the value of n increases, you get closer to compounding continuously, and that's what I tried to explain earlier in the lesson. Choice 4, as the value of n decreases to 1, the value of the account approaches the function. No, this function would show a decrease of, if you're subtracting 2%, this is a 98% growth, which would show actually a decrease. So that is incorrect. Okay. Kellyanne has $20,000 to invest. She puts half her money into an account that grows at an annual rate. Half of the amount that grows at an annual rate of 0.9% compounded monthly. So that would be, if it's compounded monthly, I'm not going to use the PERT formula. I'm going to use the other formula that I think we used a sub 0 here. 1 plus r over n to the nt power. Okay, if it's half, she's going to have $10,000 in each account. So this amount is going to start at $10,000 in the first account. It's growing at a rate of 0.9%, so the r is going to be, move the decimal 2 to the left, 0.009 over n. It's compounded monthly, so n is 12 to the 12t power. So a equals 1,000. Let's see what this base simplifies to. 1 plus 0.009 divided by 12 gives us a base of 1.00075 to the 12t power. The other half of the money, into an account that grows continuously at an annual rate of 0.8%. So that's going to get the PERT formula. A equals PERT, starting with the 10,000, because half of the original. The rate here is 0.008t. Okay, so we want the choice that has this function for half the money plus this function for the other half of the money, which is choice 4. Okay, and tomorrow we'll practice a bunch of these in class.